This tool is called Orange. In the beginning, I had mentioned that this is part of this Anaconda package. And within that, you'll get this Orange tool here. And these are open source and these are free. So there's no excuse to not learn, right? If you have time, use your holidays now to download it. It's very easy, actually. That's how I started. So let's look at let's demonstrate what I just said. Okay. So again, I'm demonstrating using this simple program in Orange. Most serious applications. I mean, you can do this also if you're trying to get your feet wet. Once you start becoming serious, you would need to understand or use Python or something. Okay, but this is very easy to demonstrate and it's very easy to learn. It's very intuitive tool. So we pick this data set from Wisconsin. Right? This is how the data table looks like. All these properties. Right. Now remember, to answer somebody's question, this was very clean data, so the difficult work was done. Now I have this nice form that I can just run a model on. So you select the columns, select rows, because you may want to exclude something, some unique patients or something, so you can do a lot. Now the first step is splitting the data into training and testing, right? So this is where I've set that percentage, put 80-20. You can use different techniques for splitting the data, but this split is usually random, so it's pretty easy. That part is the easy part. Okay. Now I'm showing here KNN, but I'm running multiple models here, by the way. And that's usually the case. You never run just one model. You run multiple models at the same time and see which one behaves better. Okay. So here's where I'm splitting the data into training and testing. I'm providing the training here, and then the test data I'm directly sending to the predictions. So this model actually already ran. So let me show you something real quick. So actually, so I ran the different models. KNN is what I explained. There's another one called SVM or support vector machine, random forest, classification tree. These are the different predictions that it made now on this testing set. So this is the actual value, because remember, this is testing data. So we did know the value of what the patient was going through, right, in this column. And then these other columns are the predictions by different models. So KNN, so let's, if you look at this patient number 1, it was benign. KNN said it was benign. Random forest said benign, 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 right? So all of the models were able to predict this particular patient correctly, no issues. Second one was also benign and so on. And if you go through all this, you'll see some of them will make some errors, obviously. So if you compare for this particular application, when I compare the accuracy, it turns out KNN was the best accuracy of 99.9, meaning out of 1,000 patients, only one patient could have a misdiagnosis, right? That's what that means here. So you always want to do multiple models at the same time, and then you pick the one that gives you the best accuracy. Okay. I did want to show you a quick preview of something called decision tree, where basically it splits the data in, and this it did that for us right now while I was speaking. Okay, so what it does was, so this is another model called classification tree or decision tree. It split the data into two parts, and what it found was if that cell size was less than 2.4, then it turns out it's a benign situation. Whereas if it's greater than 2.4, it 176 out of 197 patients were malignant. And then again, it does another split. So here it found out that if the clump thickness is greater than 7.6, 18 out of 18 patients were malignant. So the nodes are becoming, whenever you split, the nodes are becoming purer and purer, and then you're accurate, then you are able to make a prediction. So it's almost like a flow chart now. So if you have a new patient come in, you can just follow this flow chart, and then you can make a prediction that this person is malignant or this person is benign and so on. So that's model number 2, which is called classification tree. Any questions on these two models? Show me the tree again. Sure. Okay. So it created that tree. So if you're looking into the interest and more details, the technique it uses is called information gain, or it reduces uncertainty. So what it does is it tries to split. So it goes, so the sequence it follows, it goes from one feature and it kind of iterates, and it tries to see when it splits at a certain value, how can that node become very pure? And there's some technique to that, and of course, probably too much on this call, but the idea behind that is called information gain. You're trying to reduce the entropy, basically. Okay, so that's how this works. So this was an example of supervised machine learning. Oh, sorry. One thing I wanted to mention is this. There's a term called a confusion matrix, that is used to analyze data or how good your predictions are. And I always like this term because the movie Matrix is very confusing. I did not come up with this term. This is the term that they use. Okay. So what is this confusion matrix? In a confusion matrix, typically you may have these two axes. Not typically, there will be two axes. So in this case, it is an actual axis, and the vertical is the predicted axis. So in this case, right, 85 patients were benign, and the model correctly predicted them as benign. That's good. That's exactly what we want. If you look at this number, 44, 44 patients were actually malignant, and the model correctly predicted that they were malignant. That's what we want. So we want high numbers here. And this guy here, 3 patients were actually benign, but we predicted them as malignant. So this is a case of false positive. And 4 patients were actually malignant, which we predicted as benign. That's false negative. And we want to have at least 0 numbers or very, very low numbers. You'll never get perfect 0 because any test you do, right, there's always this uncertainty, unless you have infinite data, which you will never have, right? So you'll have some uncertainty here, but you're going to minimize these two cells. And each model is doing differently, and you can notice that KNN seem to do a little better than others. But this is how models are predicted for accuracy, and this is a good graphical way of representing it. It's called confusion matrix to see how your model is doing. So this was supervised machine learning demonstration. Let's quickly classify. I'm looking at the time now, so let's keep going. So basically, the supervised machine learning is split into 2 parts: regression and classification. In case of regression model, we saw that example of the house sales value. It is a numeric target variable, but you could also have a categorical target variable. In this case, it was this breast cancer, right? Malignant or benign. So supervised machine learning model can be used in both of these categories, regression or classification, based on what is the type of your target variable.